Hi guys, last part of chapter 23. Here we go, example 10 and example 11, but also talking about mean again. So if we have this notation, just a reminder from last video, x is distributed binomially. That means that it meets those two criteria. There's a chance of probability of success or failure. Only those two things can happen. We get what we're looking for or we don't get what we're looking for. And the second thing, goodness, I forget the second thing. That's all of the probabilities have to add up to 1. Each of the trials is independent of the other. That's what it is. So in order to be a binomial distribution, has to meet those two criteria. Number 1, there's either probability of success or probability of failure. You get what you're looking for or you don't get what you're looking for. Number 2, each of the trials has to be independent, which means if we're taking a sample, then we need to be replacing and so on. So probability needs to remain constant throughout the situation. Okay. If that is the case, then we have a binomial distribution, which we can use binomial expansion with, and we've looked at this already before. This time I'm going to show you also with the q replaced by 1 minus p, because remember q is equal to the failure, so 1 subtract the success. Now, the mean of the random variable x, okay, so the number we would expect to happen, this is also expectation, it can be called the mean, is actually equal to n times p, so the number of trials multiplied by the probability, and we've seen that before, a simple situation. Standard deviation now, this is new. Standard deviation of this mean we can calculate in this manner. This is the mean, so n times the probability of success, also times the probability of failure, but square rooted. If we're talking about variance only, remember this is a symbol for variance because the connection between standard deviation and variance is that the variance is the square of the standard deviation. So this would be this formula without the square root sign. Okay, so we have these three formula: mean, standard deviation, variance. All right, example 10, we have a die that's rolled 12 times. X is the number of 6s that are rolled. Find the mean and the standard deviation. So first we need to identify what does the random variable x represent. It represents the number of 6s. Okay, so what's the probability of that happening? So probability of success is p, and that would be 1/6 for any die, for getting a 6 in any of the trials, in any of the rolls. N is equal to 12 because we're rolling 12 times. Okay, so the mean is n times p. N is 12, p is 1/6. That's 12 over 6, so 2. So if we did this situation where we were rolling a die 12 times, looking for 6s, we would expect, or the mean number that we would get if we did many of these 12 rolls and then calculated the mean, would be 2. Okay, so this is the expectation or the mean, 2. All right, not finished. Standard deviation then. Standard deviation is square root of n times p times 1 minus p. So this would be n, 12, p, 1/6. 1 minus p is 5/6. And then square rooted. So that's 2 times 5/6. 5/3 square rooted. Let's take a look at that on our calculator, see what decimal number that is. .29. So the standard deviation is 1.29. So mean 2, standard deviation 1.29. All right, example 11. Here we have a batch of batteries that we're looking at. 5% of the batteries are defective. We're going to take a random sample of 80 batteries. Okay, so 80 batteries, that's what our N is equal to. And probability of success, even though our success is actually looking for the defective ones, our probability of success is 5%. Okay, we're taking with replacements, so that tells us it's binomial. Find the mean and the standard deviation of the number of defective batteries. Okay, so this is important. Defective batteries is what we're looking for. So random variable x represents number of defective batteries, and that's what this percentage was. So mean, again, n times p. N is 80 batteries in the sample. Probability of defective is this. So 80 times 0.05 is 4. So we would expect 4 of those batteries to be defective. Okay, standard deviation. N times P we already figured out over here. Okay, so we could just put 4 there. 1 minus P, so 1 minus probability of success, so that'd be 0.95. And then square root it. Let's do this on a calculator. .95 rounded properly. 1.95 is the standard deviation. So we would expect 4 of those 80 batteries to be defective, and the standard deviation is 1.95. There we have it.